In this video, we're going to talk about misleading graphs. One way that graphs can be misleading is that they omit the baseline. In this bar graph on the left, the vertical axis starts at 50, and it makes it look like whatever this bar is representing with group A is twice as many as group B, or twice as many as group C. But if you were to look at the actual percentages, you can see those bars are really representing numbers that are relatively close. So omitting the baseline makes the differences more exaggerated than they really are, and that can be misleading. Now, it's one thing to see misleading graphs from a textbook, but it's quite interesting to see misleading graphs in real life. And here's an example of a graph where they have omitted the baseline. And if you, again, were to look at just the two bars real quick, it looks like that second bar is 3 or 4 times the representation of the smaller bar. But if you were to look closely at the vertical axis, you can see that it does not start at 0. This would be a more fair representation of the differences between those two bars. Okay. Variation seems larger than what it really is in the graph on the left. And the graph on the right, again, being more accurate, the bar lengths should be proportional to the data. That's one of those keywords that's going to come up in your homework, proportional. Here's another example of misleading graphs. These graphs represent women as a percentage of all college students. With the graph on the left, it looks like there was this huge dip in the percentage of female students in the 1950s, and then a big increase. But if you were to look at that on a scale of 0 to 100, you can see there is a dip, but it's not near as dramatic as what it appears to be on the graph on the left. Here's another example where we've omitted the baseline. Here we have a horizontal bar graph, and these bars are representing the number of calories in different meals. And it looks like the calories in a Wendy's meal or a Taco Bell meal would have twice that as Kentucky Fried Chicken, or maybe 6 times as that as McDonald's, or 6 times as that as pizza. But if you look at the numbers themselves, the amount of calories for McDonald's is 600. The amount of calories for Wendy's is 720. So there's really not that much of a difference as what it appears to be, because the bar graph does not start at 0. Another way bar graphs can be misleading is by manipulating the y-axis. So here in the graph that's on the left, my vertical axis starts at 0 and it goes up to 40. The graph on the right starts at 0, but it only goes up to 15. And depending on what data you have, depends on whether the graph on the left or the graph on the right would be more appropriate. But we can see that the graph on the right does have more of a change over the years that are represented here, 2019 to 2023. And again, we can see this in a real world situation. And it's kind of hard to see from looking at this graph that's on the left here. Let me see if I can zoom in a little bit, make it a little bit bigger. You can see my graph starts off by going up by 30s, 30, 60, 90, and then it goes up by 10, and then 30 again, and then 50, 10, and then 50. So it's really inconsistent in how those bars have been spaced on the vertical axis. In the second graph, my vertical axis has been remade to where it is consistent, and the graph on the far right is a logarithmic graph. So even though my intervals are not consistent, that is appropriate for a logarithmic graph. And just to show you that misleading graphs are not just something that occurs in the United States, we have a graph here that is misleading, that is from Argentina, and this is based on information about the number of COVID-19 tests available. And it looks like that there's really not that much difference between how many tests there are available from Argentina and some of the other countries. But if we were to look at this data with an appropriate scale where those bars are proportional to the data, we can see that there's a huge difference between what is being portrayed and what there is in reality. And here's an example of manipulating the x-axis. This is hourly crime distribution, and my horizontal axis has the times from 6 a.m. to 9 a.m., 9 a.m. to noon, and then noon to 6, and then 6 to 9. So all of these bars are representing 3-hour intervals, except for this tallest bar, and it's representing a 6-hour interval. Well, because it's representing a longer period of time, it should have probably twice as many crimes during that time period as the other bars do. Another way that graphs can be misleading is by cherry picking the data, which means you're only choosing certain data that support what you want to see. And in this graph that's on the left, it's misleading because we are only looking at the few months between May and August of the year 2020. But if you were to look at more data between 2019 and 2023, then you can see a better picture of what's going on with whatever this is representing. Another way graphs can be misleading is using the wrong graphs. Pie charts are used to compare parts of a whole, not the differences between groups. So a better way to represent these differences between the groups is with a bar graph. And again, we can see here that we have a misleading graph in the real world. And this would be a more appropriate graph for that data. Here's another example of an inappropriate type of graph. Again, this is represented as a pie graph, and it should have been a bar graph. Another way graphs can be misleading is by going against conventions. Normally, when you're looking at graphs where there's shading, the darker areas are representing higher percentages. So even though it may technically be correct, it's just misleading to go the other way around. A sixth way that graphs can be misleading is visual distortion. You should never use three-dimensional pie graphs. We can see here an example of where a three-dimensional pie graph was used. And again, this graph is not from the United States. This graph is from Canada. This next graph is a graph that is in your textbook. It will be on your homework. If you are looking at how many of these little TVs can fit into this big TV, volume-wise, you would say probably at least 20. But if you look at the numbers that these televisions are representing, the little television is representing 18 million. The bigger television is representing 98 million. So that number on the right is about 5 times as big as the other one. So we would expect 5 of these little TVs to fit into the big one, and that is not what is represented in the picture. So that could be very misleading. Here's another example from your textbook. We have the quote, "The volume of our sales has doubled." Well, first of all, volume is 3-dimension, and my picture is only 2-dimension, which represents an area. So even though the side lengths of these two squares have doubled, the area has quadrupled. So your eye tends to go to the area as opposed to the lengths of the sides. Other misleading graphs would be percent change graphs as opposed to absolute value change. Nonlinear scales can sometimes be misleading. At times it's appropriate, like a Richter scale is based on a nonlinear scale. And another way graphs can be misleading, this is my favorite, is the graphing unrelated data on the same grid. And here I have a graph of the number of people who have drowned by falling into a pool. That graph is in red, and I'm comparing that to the films that Nicolas Cage appeared in. Okay, one has absolutely nothing to do with the other, but because they have the same shape, you tend to think that there is some type of correlation going on there.